Alright, our next topic dealing with continuity is the intermediate value theorem. So the intermediate value theorem, or IVT for short, says that if f is a function continuous on the interval from a to b, including the endpoints, then there exists some value c in that interval such that f of c is between f of a and f of b. Alright, so just what the heck exactly does this mean? So the setup is this: you have a function f, it's continuous over a closed interval ab, like this one that I have shown in the diagram. So what we're saying is that somewhere on the interval from a to b, there's a c, such that if I look at the functional value at c, it's between f of a and f of b. That's all this says. It seems kind of obvious, but again, it has to be a continuous function, which we sort of take for granted, right? Because so many functions that you've looked at over the course of your studies have been continuous. And it's an existence theorem, so we're just saying that it's there. We're not saying exactly what it is. Let's look at some examples of some realistic scenarios where we can see this intermediate value theorem at work. So suppose we've got a vehicle starting at an intersection and that eventually reaches a speed of 50 miles per hour. So we can plot this on a speed versus time graph here. We're starting at rest, so the first point here is just the origin. But then after so much time, eventually that speed gets to be 50 miles per hour. So if we look at the graph of this thing, I mean, the speed might have fluctuated or what have you until we get to that spot. But here's what the IVT says. So for example, there was some place in time where the speed was exactly 35 miles per hour. So somewhere on here we can find a place in time where that happened. That's the c value that we're speaking of. We're just saying that somewhere between the time we started at rest and the time we ended up at 50 miles per hour, at some point the speed of this car was exactly 35 miles per hour. Okay, so here's another more, I guess, mathy example. So we're going to use the IVT to show that this equation, x times the natural log of x equals 3, has a solution somewhere in the interval from 1 to 5. We're not going to find what the solution is. We're just going to show that a solution exists and it's between these two values. One quick note here before we start. We know that y equals x is a continuous function, and we know that y equals natural log of x is continuous, at least over the positive real numbers. And on 1, 5, they're both going to be continuous, and so their product is continuous. It's important to note that because the intermediate value theorem only holds for continuous functions. Also, a big tip on this one: rewrite the equation so that the 3 is on the other side, so that we're just checking to make sure that the signs change. And again, that will become clear, I think, in a minute. So I'm going to write x times natural log of x minus 3 as a function. So thus, if you plug in the endpoints, then you see that putting in 1 gives us a negative value, putting in 5 gives us a positive value. And so since 0 is in between -3 and 5 times the natural log of 5 minus 3, by the intermediate value theorem there exists some value c which will satisfy the equation c times natural log of c minus 3 equals 0. So a solution to this equation over the interval 1, 5 does in fact exist.